All right, picking up where we left off with section 6.5. The side angle side similarity theorem, which, yes, should be SAS, not SSS. If that's what it says in your notes, you can fix it. If an angle of one triangle is congruent to an angle of a second triangle, congruent, you can use the symbol for congruence if you'd rather, and the lengths of the sides, including these angles, that's an important word, are proportional, another important word, they're not congruent sides, just proportional sides, then the triangles are similar. I'm pointing these things out because this is a little bit different from when we did side angle side for congruent triangles. Angles are still congruent, but now sides are proportional. So here they marked our congruent angles, so we can start with that. So if angle X is congruent to angle M, and we should be making a proportionality statement about the sides that include those angles. So give me one side from the first triangle on the left that I would have to use. Okay, XZ is one of them. That should be compared to which side from the other triangle? MP. And that ratio would have to be equal to what other ratio? XY over MN. Okay, so this left side of our angle in a ratio with the left side of the other angle is proportional to the kind of right-ish side of that angle to the right-ish side of the other angle. We cannot use side ZY or PN in this case because they are not including that angle in either triangle. If all of this is true, then we could say that we have similar triangles. Again, you get to choose how you name the first one. Bless you. How do you want to name the triangle on the left? Okay, we could name it XZY. If we name that triangle XZY, the other one has to be named how? MPN. Again, if you switched up the order of the XZY, then the MPN would also get switched up. All right. Are the triangles similar? If so, state the similarity and the postulate or theorem that justifies your answer. So we on these ones are not necessarily just using side angle side similarity. There were some other similarity theorems and postulates that we learned before. So I'll put them up here. One of them, of course, was the SAS we just talked about. Who can tell me another one? Heard a very quiet SSS similarity, side similarity. There was one other that we learned that was not in the 6.5 notes. I believe it was 6.4 notes. Very good. Angle similarity was the other one. So there were 3 different ways other than being able to know all the sides and all the angles. There were 3 shortcut ways of knowing that triangles were similar. So, for our first pair of triangles, as it stands right now, can we use any of these 3 ways? No. With what they gave us right away, none of these things fit. But which one should we look a little further into? Angle similarity. We don't know anything about the sides, so we cannot use those for sure. But they only marked 2 angles in each, which leaves us 1 angle in each that we don't know anything about yet. So we should dive a little deeper before we rule out angle. How can I find my missing angle in these triangles? Micah? Good. Add them together, subtract from 180. So if I take 57 plus 92, I would get 149. And then I take 180 minus 149, and I would get 31. Okay, so this angle C is 31 degrees. Do you think I need to find angle D? Not really. You can, just to be really thorough. But if 41 doesn't match the 57 or the 31, then angle D isn't going to match either of them either. So if this is 10 more, I would expect that one to be like 47. Okay, which we could find it, add the 41 and the 92. That would give us 133, take 180 minus the 133. That gives us that 47. So this shows us for sure we don't have 2 pairs of angles. These are not similar. If they are not similar, do not write a similarity statement. Just tell me they're not similar and move on. If they are similar, that's when we'll write a similarity statement and say what theorem we used to show it. Questions about letter A? Okay. On letter B, anybody have any thoughts? Anybody have any thoughts on which ones we probably should not be looking into? Angle is not going to be useful because we don't know any angles, which means side angle side is also not going to be useful because we don't know any angles. So which one are we thinking about? We're thinking about side. Now the tricky thing is they didn't tell us any of the side lengths, but they did mark some sides congruent. So if we need to, we could kind of play a game where we just say, well, I don't know what this side is. So you could pick a number or you could just pick a variable. Usually if we don't know something, we use a variable. So if I labeled side CM with a little X, then that means I could also label CT with an X, and I could also label TM with an X. Okay, I don't know what they are, but I know they all have to be the same. Same thing on the next triangle. I could label side AR with a Y, which means that AS and SR also get labeled with a Y. So then if I'm looking at ratios of side lengths, no matter which sides I pair up from one triangle to another, what's my ratio going to be? What over what? It could be Y over X if you're going from triangle ASR to triangle TCM, or it would be, if I go the other way, X over Y, but it's always going to be the same ratio. It doesn't matter if I take CT and compare it to SR, or take CT and compare it to AR. Any pair of sides I choose is either going to be Y over X or X over Y, depending on which triangle I'm looking at first. Does that make sense? The ratio is always the same. So does side work? Yes, it sure does. Yes, they are similar by side similarity. They want us to state the similarity On this particular problem, there are a lot of possible correct answers. It would actually be kind of hard to come up with an incorrect similarity unless you just use the wrong letters. So name the first triangle however you want. This should be easy. You get to pick. CTM, okay. Is similar to, and then the other triangle, it doesn't really matter. So I heard ASR first, so that's fine. Remember, if all the sides of a triangle are congruent, what does that mean about all the angles? They're all congruent, and they are all how many degrees? 60 degrees. So really, any angle could get matched up with any other angle in the other one. Technically, if you reasoned your way through it and told me equilateral triangles are equiangular, you could have argued angle here or side. But you would have had to have explained to me why you knew these were all 60. So in my opinion, side is easier to get to right away. If you got really technical, you could argue the other ones. But that's why it doesn't really matter down here. As long as C, T, and M are all used together, A, S, R are all used together, you've got lots and lots of possibilities. Questions, concerns? Need more time? This is kind of a special problem. I don't know that you'll necessarily see a lot that are like that. Okay? Next couple questions are the same kind of thing. So I want you to take a few minutes to think through the list of possibilities. Side, angle, side, and angle. Think about what you know about those triangles. Think about what you could figure out from the information they gave you. And see if you can show any triangles to be similar. All right, probably the easier one to talk about is going to be letter C. What did we come up with there? Okay, they are similar by side, angle, side. You don't necessarily need to talk about the angles. You could state, angle D is congruent to angle V because they're both right angles. If this were a proof, you would have to make a statement like that. For a problem like this, it's not necessarily a proof. You don't need to say that. What I would need to see, though, is the sides being proportional. So, for example, I would need to see that you compared the side that had a length of 6 to which other side? 3. Okay, 6 is smaller than 8. So you need to compare it to the smaller side of your other two sides. Does that make sense? Why it has to be the 3?
Yeah.
Okay. Small to small, big to big. 6 to 3 reduces to be 2/1. But we would still need to show that we compared 8 to 4, which also reduces to 2/1. So the fact that we have a pair of congruent angles and the sides around them are proportional, then yes, we could say that side, angle, side similarity worked there. The last thing would be to state our triangles. Okay, first one you name however you want. So FDM is similar to AVQ. Okay, if you named your first triangle FDM, you have to name the second one AVQ. If you switched up the order of the FDM, then yes, the AVQ would switch up as well. Questions about letter C? Okay. So, can I take this away so that I can redraw these separate with a little space? We're all good with letter C? Okay. Then let's just take it all away. And we'll separate out these triangles. So one of them is that big one, MQN. That's close enough. So we had a right angle there at N. Q. And then our other one was this small one, PNO, it looks like. Ooh, too long. There we go. PNO. And we know a little bit of information about these that we don't have marked yet. We know that angle N in our small triangle is also a right angle. Okay, remember, if you've got two lines that meet at a right angle, there are technically 4 right angles that would exist all the way around. The other part is that we know that PN is congruent to QP. So if I were to label PN with an X, what could I label QN with? A 2X. Okay, now if you really need to use numbers, you could do something like a 5 and a 10. So we could figure out a ratio there. Is there anything else we know or could figure out here that we think? Yes, ma'am? Do we have a reason we could say that? Perpendicular lines don't necessarily give us congruent segments. Do we know that it bisects?
Yeah.
Did it tell us that it bisects?
No.
Did they mark it that it bisects?
No.
So can we assume that it bisects? No. Even if they said bisects, that would actually show that these definitely are not similar. If MN and NQ were exactly the same, that would actually throw off the ratio. Right now, the ratio is 2 to 1. So if these were 1 to 1, then our ratio would definitely be off. But we don't even know that. If they don't say bisects, we don't know bisects. All they gave us was a right angle. They didn't tell us that it was a perpendicular bisector. Any other thoughts? Okay. So, can we use side angle side? No, we've only got one pair of sides. We don't have the other pair around it. Can we use side, side, side? No, again, we already said we've only got one pair of sides, not all 3. What about angle, angle? I'm going to say that's also a no. They only told us one pair of angles, and I don't think we have any way of proving any of the other ones. So, in this case, I would say there's just not enough information. It's good to think through all these possibilities. If they'd given us some other segments, like if we knew that QO and QM were the same, then we would know that that's a perpendicular bisector. They didn't fill in anything else for us. Questions, concerns about letter D? Need more time on it? Ready for our word problem? All right, a large tree has fallen against another tree and rests at an angle as shown in the figure. What theorem or postulate can be used to show that the triangles in the figure are similar? So what are our options? Okay, our options are side, angle, side, 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 and angle, angle. Which one do you think we could knock out right away? That's not going to be the one we use. Why do you say side, angle, side? Good. So we only have the little hypotenuse. We don't have the big one to compare it to. So I would agree side angle side is out. If side angle side is out, which other one do you think has to be out? Side, side, side. They didn't tell us all the sides. They didn't mark this side. They didn't mark that side. Now, technically, we could figure out this last little side, right? Pythagorean theorem and all. We've got two sides. But for this big one, they only gave us one length. They didn't give us either of the other two. So at the moment, we could not figure them out. So the only one we can really check would be angle, angle. We already have one pair of congruent angles. Which ones would that be? The right angles. Do we have a second pair?
Yes.
Yes, where? Give me direction, like top, bottom, left, right. Left side on the bottom. This angle down here is going to be congruent to itself. So remember, if we were to separate out these two triangles, the little one and the big one share that little angle there where the tree's leaning against the ground. Does that make sense? Questions, concerns about it? We're talking about the little angle that's made where this tree is leaning against the ground, kind of. This bottom left angle is congruent to itself. If we were to separate these two triangles out, we'd have the little triangle, and then we'd have the bigger triangle, but both of them had that little angle down there in common. So those little angles would have to be the same. And then we also have the 90-degree ones. Questions about how we're using angle-angle similarity here? 90-degree angles and reflexive property lets us use angle-angle similarity. All right, the last part. Find the length of the tree that fell to the nearest foot. So that means we're looking for the length of this tree that's tipped on its side a little bit, the slanted one. We could find the height of the other tree that's still standing, but the one that fell, we're looking for that side. Which means we have to set up a proportion. Give me two sides that we know that we could compare. Okay, we know the 28 and the 8 feet. And that would get compared to what? X over 10. If you have this switched around a little bit, there are equivalent proportions that would get you the same correct answer. But no matter how you do it, you should be taking 8 times the X. And you should be taking the 10, sorry, not over, equals 10 times 28. So 8x equals 280. When we divide, what do we get for x? 35. My units are feet. Did it come out to 35 exactly, or is that after you rounded it? 35. Okay. Questions, concerns? Need more time? Warm fuzzies? Mm-hmm. Feels like the air finally got hotter. That's good. Okay. Your homework assignment, I think, is a little bit different from this because we split it up. It should be on your assignment guide. You should have done day 1 for 6.5 on Thursday or sometime over the weekend. So you should be working on 6.5 day 2. Should be on the same pages.